sometimes the built-in functions in MATLAB and Octave don't work on data or some situation that you're in. And so you have to resort to lower level programming techniques. This video is about using C-like functions, the programming language C. C-like functions that are in MATLAB and Octave. If you haven't studied C, I have a whole video series on that, but this is mainly, you may get completely lost in this video, and this is mainly for my students in my class to do what they've already learned C, and so now they're learning MATLAB, and so this is to help them use things that they learned in their C programming language studies to apply to MATLAB. It helps MATLAB become more powerful, especially when faced with when ordinary built-in functions don't work. That's what we're going to do. I've used the following example. Suppose you get a calibration data file, right? And I'm showing it here. In the past, we just had an X column and a Y column, and so it was just the numbers in the data file. Especially in the olden days, old data, there's going to be other information in those data files as well. And what computer scientists and people call that is headers. So a lot of data files have headers. They tell you information about the data file itself. Where was the data collected? When was it collected? What instrument was it collected on? All those kinds of things can show up on the header of a data file. Right? And so, but the fact that it's not just straight numbers can create problems for MATLAB, and I'm going to show you right now how that works. Let's go into our file manager, and we're going to make a new folder in our Octave directory called load calib. I'm going to load this calib data. I'm going to put that calib_1.txt file in that file. Then I'm going to go into Octave, and I'm going to get in the right folder. So I click on the browse and get to the right folder, this folder load calib. When I run load, the function load, which is what we use just for XY data file, I wrote load calib_1.txt, boom, it gives you an error. I can't do that. It's weird. It's not the right format. So we're gonna have to do something low level. We're gonna have to open the file and read it line by line, that kind of thing, in order to be able to tease out the calibration data from this data file with a header and a footer too. It's got a little N there at the bottom. Good? That's what load calib is gonna do. So I edit load calib.m. I bring up the M file. I'm gonna do the standard things that you do in an M file, which is clear all and close all, clear the baffles, make sure the workspace is empty and there are no figures open, that kind of thing. Then I'm going to use the fopen command. There is an fopen command in MATLAB as well. Instead of using fp, like we do in C, I'm going to use fid. Fid is just more common in MATLAB help files, and so a file ID is what I think they made it stand for. So FID is fopen, and then calib_1.txt, and open it as a read, read, right? The next thing is I'm going to use the fgetS command. So you can get a line by line. So the new line thing is going to end, is going to be when fgetS stops, and it's going to put that into a variable. The variable is going to be called new line. So new line is going to be a string, and it's going to have each line, the next line in the file, in this case the first line, read into that string, into that variable. Good. So that's what this line thing's going to do. Fclose. So I'm going to have to do the fclose housekeeping command too. And so then I run load calib, and lo and behold, if you look, it just new line is just equal to the first line, the string as a string. See that? So so fgetS works too. So fopen, fclose, and fgetS works too. Now what I want to do is I want to interpret all the lines in the headers. First off, you can get the number of points. If you notice, the number of points is in there in one of the lines. And second, I want to find when start happens, when the phrase start comes up in the header, because then I know the very next line is going to be the actual data, and I'm going to start actually reading the data then. So those are the two things I'm looking for, and I need a control structure for that. When if f get s reaches the end of the file, it returns -1. So I read the first line, and then I say while next line not equal to -1. So the not symbol in MATLAB and Octave is the tilde, the curly, the wave like that. Good. So so as long as it's not equal to -1, keep going. That's what this while statement is going to do. So I have while and end while. Again, in MATLAB, there's no end while, there's just end. So put end instead of end while. I want to look for two things here. So point find is str find. Str find is like str in C. So in new line, so in the line, does the string point appear anywhere in that line? Right? That's what str find does, string find. And then is empty means if it doesn't, if there's no string points in that line, it's going to come back empty. MATLAB's going to say that's an empty set or something like that. So there's a function is empty. So if not is empty, right? So tilde is empty. If not is empty, that point find, right? Then you found it. You found the line that's going to tell you how many points it is. So then I'm going to set number of points equal to, and then there's a function str to num, string to num. A to I is a similar function in C, which you haven't used yet, but you can convert strings to nums and nums to strings and back and forth. So string to num is that. And so what's returned to point find is the index of the first character, P, where the P is. So I have to go forward a little bit. So I added 7, POINTS colon, right? And then so I went plus that to the first space after the where it says points colon, and then to the end, right? To the last point in new lines. So the string that I'm going to convert to a number is going to be space, 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 10, space, space, something, right? So there's going to be some spaces before and after, but it knows how to deal with that. And so NPTS is going to have the number 10 in it, right, from that line. So I did that. The next thing I want to do is I want to do string find, str find, start, right? So I compare new line, does it have start in it? If it does, then just set new next line equal to -1, and then it'll jump out of the while loop. You'll know that the next line is equal to the number, the first row that has the points in it, right? So that's what that is. If not, so if the string find returned a value, right, then set next line equal to -1. If not, go grab a new line. And then we'll do the same thing over and over again until we find both the line with the string points in it and the line with the string start in it. That's what this little structure here is going to be. Again, in Octave, it's going to be end if and end while there. It's just going to be end for both in terms of MATLAB only. I'm going to show you a MATLAB script in a minute here. Good. All right, so then I want to do a fgetS after that while loop down below to see if I got the string that's going to have the first 2 points in it. So that's what this code's going to do. I save it, I go back into the command window, and I type out load calib, and lo and behold, no NPTS is 10, and the very next line after I found start is the first 2 points in the calibration data, the first XY pair in the calibration data. It worked. Cool. Okay. So then I want to read those values in. Okay, so in order to do that, I want to use the fscanf statement. I want to scan each line, format and say, I'm looking for numbers here, right? Because now for the next 10 points, I'm looking for numbers. So because I know how many points there are, I'm going to use a for loop, for I equals 1 to NPTS, right? And then end for at the bottom. Inside there, I'm going to do an fscanf statement. Fscanf works a little bit different than it does in C, in that the outputs to fscanf is going to be on the left-hand side of the equal sign, A. I'm just going to make a vector A. And there's going to be I'm expecting 2 floating point numbers. You can use %G, %F, %E, any of the % characters that we've used in C. And then At the end, you need to tell it what size you're expecting. So 2 by 1. I mean, each time through, I'm expecting a 2 by 1 vector, right? And so the first element of it is going to be x, and the second element is going to be y. So I say x sub I is going to be equal to a sub 1, and y sub I is going to be a sub 2. And so that's how that for loop works. When I'm done with that, I'm filling up x and y, and so they're going to end up as a long one row, all columns, right? And so I'm just going to transpose them so that they're tall. That's just my preference. And then I'm going to put them in together, x space y, in brackets, and then no semicolon. So it's just going to print out the xy data as numbers, and I'm going to see, did it work? Did the program work? Okay, so just before I run it, I'm going to show you what that code looks like in MATLAB. So this is the Octave code is here. In MATLAB, the only difference in all that stuff is that everywhere in the Octave code you see and for and while and if, you just see end. So that's the only difference between when you see it in MATLAB and when you see it in Octave. That's just this detail I wanted to emphasize in this lesson. Okay, let's go back to the command window. And we're going to run load calib, and lo and behold, the XY pairs come up as numbers. It looks good. And if you look at the workspace, you can see that x is a vector 10 by 1 and y is a vector 10 by 1. Nice. All right, I'm good. I want to run the linear regression on that data. How would I do that? Okay, so first thing I'm going to do is I'm going to go back into the load calib script. I'm going to erase that little XY output thing. I don't need to see it anymore. I'm done. So load calib I'm going to leave load calib alone, right? I need linreg, so I go back into linreg2. I go into linreg2 folder. I take linreg.m and I copy it and paste it into my load calib folder. So I have linreg in that folder as well. Good. So I can use that function in that for load calib as well. The next thing I'm going to do is I'm going to make a whole new script, an overall script. So I'm going to call that run calib. So I'm going to say edit run calib.m. So it's going to have 2 lines in it. First thing I'm going to do is I'm going to call load calib, no .m, just load calib. Then I'm going to call linred function, m, comma b, comma r2, all in square brackets, equals linred xy. For run calib, I didn't need to do clear all, close all, because I know load calib already has that in there for it, right? The lesson here is that a script can call a script can call a function, we already knew that, but a script can call another script. So run calib is just an overall organizational thing to say, okay, load calib has all these details about getting rid of the header and all that stuff, and I can outsource that to just load calib. And so with run calib, I'm going to say load calib and then run the regression. It's really obvious what run calib is going to do, right? It's just 2 lines. And so it's another way that you can be modular in code. A script can call a script. Good. So then when I go back into the command window and I type out run calib, it did load calib. It's transparent. Nothing happened. Nothing got printed out, and it just prints out MB and R squared of the data, and it's the right answer. What did we learn? We learned that MATLAB and Octave can do C-like commands, file interactions, fopen, fgetS, fscanf, right? We learned about loop structures and how sometimes loop structures are necessary when you can't vectorize and you have to do things manually. And so different control structures, the while loop, the if statements, if else statement, and the for loop are also available in MATLAB and Octave. And then we learned that scripts can call scripts and even add to our modularity of our scripts and programs. This shows that MATLAB is really, really powerful, and the built-in C-like functions make MATLAB and Octave an incredibly powerful tool.